Are you able to hear me? Yeah. As I told you, please use your chat box for communication, man. Okay. Your microphones will be in off state because we do not want to have the external disturbances from the other people, man. Okay. So I hope yesterday you were able to catch up with the constructs like what is exactly decision making and how many types are there. See, these all introductory things, what we are speaking now, this is our responsibility in practical side in completing the course. You can understand that I'm putting the agenda of the course in front of you very seriously. Okay. Now, technically, whenever you're working with any kind of, so like machine learning approach, now I think we need to have clarity on what kind of algorithms could be technically supporting these areas. Because the whole artificial intelligence and machine learning is a construct of dependency of algorithms. Now, here, be very careful with one point. Don't ever cross compare your data structure algorithms with machine learning algorithms. If you are already a programmer, this is one thing that you will do as a mistake in cross comparison, thinking that the algorithms of machine learning are equal to the algorithms of data structures. If that mindset is there, and if you're a programmer, generally that is a very quick kind of mindset that you'll be developing that can technically keep you into trouble. See, algorithm is always what? It's an approach. Yes or no? It's an approach in doing any particular piece of the work from beginning to ending effectively. So machine learning, which can make you build very highly intelligent systems that can automate this particular world, there is some approach what we have to follow. So all machine learning algorithms are nothing but algorithms that will tell you the approach to implement AI with highest intelligence. So, artificial intelligence is a straightforward formula. Be very clear. But making that intelligence to get applied in the dynamics of the changes that are happening in this world, we need machine learning. So, these two are tightly integrated with one another. There are many number of algorithms that really come in the factor of your constructment, but be careful. Certain algorithms you should be always clear. When I come to machine learning, whether we are covering these algorithms or not, we will check. So the algorithm in decision making are what? Which algorithms dominate in decision making? One is your decision trees. So if you said that you have worked in some projects in decision making or decision making constructs, you have taken and you have worked in those projects, then he will simply ask you one question. Can you tell me in your project what you said that you have been implementing decision making as an approach of machine learning, which algorithm you have implemented? Everybody will give a list of algorithms, man. But when we tell them this algorithm, where did you apply in your project? Or in your machine learning experience, you said you have. Can you tell me where exactly this algorithm has been applied? People can't answer. AI and ML, you can always be successful in your career and your job only when you know area of application. If area of application is not given by you, we will understand that you are a stereotypic learner in AI ML, but you're not a serious practitioner in AI ML. Be very clear about it. Suppose your resume carries that you have done some fraud detection project. the first question he'll ask you is fraud detection, what you have done comes under which type of machine learning? Many times students will try to give a chance. Can you tell me? Supervised, unsupervised? No. Don't get into your constructs in a wrong way. Which kind of machine learning approach you have applied? Then you should say, sir, it's a decision-making approach. Okay. In this, can you give me the algorithm that you have taken as a criteria for your implementation? There can be many algorithms. At least one of the algorithm that comes under this particular category, you should say. In this category, you can apply many different kinds of algorithms. But at least one of the algorithm you should say which falls into the category to solve fraud detection. So these decision trees, exactly what they are. We look into these things in more detailed concept when we go for machine learning department. According to machine learning, decision trees are considered like a tool. Decision support tool. It is one kind of decision support tool that fundamentally uses a tree-like graph of decisions and their possible consequences. See, when you want to confirm somebody is doing fraudman, how you confirm that he is definitely doing fraud? So there should be multiple different number of decisions under which you could have come into this conclusion. Yes or no? So decision trees, when you supply the data, they will cross-analyze that particular data in patterns and they'll give you a set of branches. It divides the whole decisions into multiple different branches, giving impact of the score, impact of the rank, under which it can be definitely considered as a fraud. Now, finally, it may give you some suggestion. Taking that suggestion, if you make a call, maybe you are correct, you're wrong. So don't you think that you need to hit the correct person with respect to the correct area of reality? The best example I'll tell you, how many times you thought that you definitely will take a loan when a loan caller is calling you, man? I think out of 100 times they called you, 99 times you have rejected their calls. Am I correct? So don't you think the decision tree is failing? You cannot say it's failing. Decision tree will give a suggestion. Are you getting me? In multiple different number of patterns and parameters, it gives a suggestion. Finally, the telecaller with his common sense or with her common sense is making a call, expecting that this person may be definitely in reality of the loan or requirement of the loan. So it's not directly telling you this is perfect. It's giving you possible consequences. Is that point clear? Now, how it fundamentally works. On the very high level, I'm trying to speak about this one. We'll go very deep when we are getting for practical implementations in machine learning part. But these basics, what I'm trying to say, they should go and fit in your brain by the time we come into that location. Now, a tree is a collection of nodes and branches. Do you agree with me? Now, every branch represents a multiple set of nodes once again. Am I correct? And somewhere the tree will start, and that location from where the tree is starting, we call that as a root node. Do you agree with me? And the tree expands itself in multiple different number of nodes called as branches, and finally settling down with nodes that cannot be extended further, which are called as leaf nodes. Am I correct? The same terminology will happen here also, but you should know which one should represent what. So each internal node represents a decision based on a feature. Means from the root you started. Root is not a decision. Root is an area where your first idea for decision has started. Am I correct? Now, from there, the root has split into multiple different number of nodes. If 5 nodes have been split out of the root node, means there are 5 different decisions on which these branches have been created. Am I correct? So each branch is what now? Each branch of node is what? It is a feature that is representing on which decision that particular split of the data has taken place. And each node in the split can further split into multiple different number of subnodes once again. If that node is splitting, means there are multiple different factors which are favoring for other level decisions once again. That's how you should understand every internal node represents a decision based on a particular feature. Now the question is, if you don't supply proper features to understand how exactly a decision can be taken, now your algorithm in final implementation will fail or not? Now, who will supply these features? Who will supply these particular features which are becoming a decision-based node now? Subject matter experts or domain experts, and we call them at highest level as what? Data science experts. They will tell you. That is the reason if a company is unable to put its budget on data scientists, then are they not expecting you to behave in that way because of your 10 or 15 years experience in the industry? Therefore, AI ML is not a straightforward job, man. Remember that. It's a multi-skilled area which you should adapt. That's why I was having some queries yesterday. Sir, I'm something like a DB, I'm something like an administrator. Whatever you are, you need to take your domain of your experience, integrated with other ones that are not existing, and then you should pick up yourself. It's not just blind coding here. Now, once this decision-based feature has been identified on the main data, don't you think that it is now splitting into next level branches? Therefore, each branch represents an outcome of a decision. Means, shall I go further or shall I stop here? Shall I conclude that this is exactly what is the decision that can be taken? This all kind of constructive here and there buts and ifs will be applied at this level. And then finally, we should reach the leaf nodes. Okay? Leaf nodes, where leaf nodes are the final decisions or classifications what you're taking. If you don't have clarity on the construct of these things, man, then technically, do you feel that you can finally take a decision in this process? Let us understand one thing. I think your CIBIL score is one that basically confirms whether you are suitable for a loan or not. Am I correct? Maybe in other countries, they may call that as credit score, whatever it is. Now, let us say like your CIBIL score is more than, say like 7 is the cutoff point, and it is more than 7.8 or 8 man. Don't you think it's a very wonderful CIBIL score? Hello. Now imagine that taking the CIBIL score value, you are getting loan calls every day saying that please take a loan, we have a personal loan, we have that loan or that loan. But you're not interested. Now imagine CIBIL score is one of the feature, man, on which the calls are made. That's the reason out of 100 calls, only 2 calls could be successfully satisfied to the loan management systems, because 98% of customers, they reject the calls. They're looking only on one feature, but the other features what they should take. CIBIL score only tells you what, are you repaying the loans perfectly or not? Am I correct? On a repayment, it is trying to speak about the CIBIL score. But the other aspects of features that should be considered is what? How many loans this person is already having is also one of the calculation that should be taken or not. Now, this person is having 5 loans, let us say, and is repaying all the 5 loans in time. No defaulting state. Now, imagine his actual income is, say, like monthly 1 lakh, and is having loans which are fundamentally eating up 60% of his actual income. On the remaining 40%, can I give a loan for this person? What is your decision? Can you tell me? It may be yes, it may not be no. Why? Because 40% is huge. 40,000 is having in his hands every month. Out of that 40,000, another 20,000, I think he can definitely try to correspondingly apply, and he can technically be very happy. Am I correct? But let us assume if you take this particular feature, you're coming to a decision that he can take the loan. But I think the number of dependents is another kind of feature that should be added into this. Is expenditure through those dependents also should be considered? So can we take decisions on one feature here? So more the number of features you add, don't you think that your decision is getting more polished by the correctness? So generally, when you say that you have implemented decision trees, say like you kept one project, and I'm asking, can you just tell me what's the kind of algorithm you have implemented? Then you are saying the decision trees. Then imagine that my next question will be, can you tell me what are the features that have been considered for this? And you're unable to speak on the features, man. Don't you think that I will consider that you have never worked on a real-time case? That's how they will catch you in artificial intelligence and ML algorithm, ML interviews, man. Are you getting me? So the features are very important here. If the features are never spoken, technically you cannot really consider the things to be applied and associated. Do be very clear. So just imagine I'm taking some decisions like this. If income is greater than $50,000, then classify as high spender. Because you're getting more income, you are going to spend more amount of money. It is okay, but can you confirm that particular thing as a decision, man? No. So sometimes the features here, I'm taking how many features into consideration? Here I'm taking how many features into consideration? Only one. Income. Income is my feature. High spender, low spender is only one final decision I've taken. But with the single feature, can we really confirm the criterial behavior anywhere? Therefore, remember why decision trees can fail. The number of features you give less, then technically the final outcome of the decision can be a failure. The more the number of features you give, there may be sometimes overfitting also. Are you getting me? That also you should consider. Certain terms we will understand as we go through. So when you are speaking on an algorithm, you cannot speak on the definition of the algorithm anytime in AI ML. In data structures, when you speak on an algorithm, you can just speak on the definition. But here you should speak on the application. Am I clear? So I'm just trying to make you build your attitude towards AI ML now. Try to understand that. Try to understand that. Now, what are the advantages when you take any particular algorithm? Every algorithm has certain constructive advantages. Many times people will go for decision trees because it is very easy to visualize and interpret. Now, the one of the feature of advantage what decision trees have is it can handle both numerical data and categorical data. Numerical means data which is in numbers. Categorical data means it's not in numbers. Say like eligible for loan, 0 and 1. 0 is for not eligible, 1 is for eligible. This is numerical data. Categorical. Eligible for loan, yes or no. This is categorical data, which will be generally in the construct and composition of what? Strings, okay, text based. We'll understand these things at the later stages, but when you come to decision trees, either it is basically numerical data or categorical data. In both the cases, this algorithm can be implemented. Now, what are the disadvantages? I told you, if you don't take your features very properly and you try to think that more the features, more accuracy, that's wrong. Because there's a great lot of chance for prone to overfitting with complex data sets. When your data set is very complicated, there's a chance of overfitting. At the same time, it can become unstable with small changes in data also. Any small changes are happening in the data, the whole algorithm can become unstable and the tree can get readjusted once again. So balancing yourself is very, very important when you're trying to deal with your decision trees. Am I clear? That is what is machine learning, man. That is what is machine learning that comes into the picture for us. It's only conceptual preparation what we are trying to do to handle the constructs at the later levels in an effective way. There are some key points you should definitely catch when you're dealing with your construct and composition of decision trees. Jay, I will be adding up every terminology in a practical state, okay? Just let us wait, okay? Now, one of the point you need to catch is what? The numerical data. So anything you call it is numerical. Any numerical data is measurable or it's non-measurable. Measurable. Now, generally, numerical data is measurable quantities and it is always expressed in numbers. People coming from data warehousing, when you come to the construct of the data warehousing, we have only two types of data representation. What is that? Tell me. We have only two kinds of data representation. What is that? Dimension and fact. Yes or no? Now, facts are generally what? Facts are generally what? Numbers, measures. Yes or no? So, cross comparison from other areas, if you are coming, you need to understand. So, the whole world is same, man. The only thing is you are putting that concept into which kind of container. According to that container, the shape and the strategy of the terminology changes. Get ready. Now, these numerical data, catch up very carefully. These numerical data, which is a measurable quantity, which is helping you in taking your decisions or any other kind of algorithms wherever you're operating, is further classified into two types. Okay. See, I'm concentrating on the concept and I'm concentrating on the terminology simultaneously such that we don't do them as individual definitions, individual discussions and get confused. Is that point clear? So my whole course will be like a multi-integrated statement. Therefore, on that area, when I'm discussing, you should concentrate very carefully. Else what happens is, I can take my construct like I keep what is numerical data, give you some definition, but you'll never understand where it gets applied. So get up. So numerical data in AI and ML, when you come in, is classified into two types once again. One is called as discrete numerical data, which is nothing but counts that can only take certain values. Means wherever you're having numerical data that is giving you counting ability, that is called as discrete. Like number of students, number of sales, this is basically discrete numerical data. Am I clear? The second kind of category of numerical data is continuous numerical data, which is measurements that can take any value within a range. Now, whenever you're analyzing, height is say like you want to find out what is the average height that is basically confirmed for a student studying definitely in 9th class, let us say. Then can we directly tell that height as it is, man? No, because all students in 9th class may not be in the same height. But when you are confirming the decision, how you'll do, you'll try to take certain things like find out how many students are in the range of height with 100 centimeters to 110 centimeters. How many are from 111 centimeters to 120 centimeters? Yes or no? We take a discrete of range and we'll be working continuous. So such kind of data is called as continuous. Am I clear? So you need to have clarity. When you see a numerical data in your data set, why I'm telling you this is, when a data set comes to you, when you're looking into some numerical data in the data set, you should have clarity which particular numbers are important for me in my decision making. And these numbers, they are discrete or they are continuous. I should have clarity on that. Is that point clear to you? No data will come directly saying that this is discrete and this is continuous. Be careful. So it is our common sense with which we should come to conclusions or not. So now the question comes, sir, how to identify? How to identify this numerical data or anything? Simple man, look for columns where the values are numbers, and these columns can be mathematically manipulated using aggregated functions like sum and averages. Suppose like you take an age column, and age column is calculatable or non-calculatable? Calculatable. Average of age. If I take that column called as age, and if I say average of age, am I not getting the average of that particular sample of data's average age of people? The same I'm having salary column, let us say. Don't you think that I can say sum of the salary, average of the salary, maximum of the salary, minimum of the salary? Therefore, people who are coming from databases, if you are very good in your group functions and group by clauses, don't you think that you're almost all ready for the sake of understanding the data, which is numerical by nature and which can hit your decision making process? So be careful. Everything. That's what I'm saying. Many times students ask me, sir, what kind of qualification I should have to become AML engineer? There's nothing anywhere in the world it is written, man. But finally, when you enter into this field, identification of data is at least the minimum qualification you should have. The category of the data is a minimum qualification you should achieve. The type of the data that you need to handle with and you are handling is something, a qualification that you should achieve. The sensitivity of concentration, identification, classification, and categorization, if it is not there, and you're not ready for it, you're not suitable for AML fields, you learn any technology that is basically going to be waste. Why? Because finally, after you tell AI can do something, AI cannot do automatically. AI can do automatically for end user, but as a developer, you should say no. Catch up those things. Are you getting the clarity now? The second kind of data is basically called as categorical data. Okay. One is the numerical data, the other is the categorical data. In relevance to that particular constructive algorithm, immediately I am cross implementing the definitions. Okay. So that you can catch then and there itself. Now, what is categorical data? Categorical data is such kind of data that always represents characteristics or qualities that fundamentally makes your actual system to get identified in a divided state, which can make your system to get identified in divided categories or labels. Now, this categorical data is what? Let us understand one thing. I want answers from you people, man, because majority of the students, definitely you could have come from database as minimum background. Therefore, I'm asking you. Or even if you do not know databases, sir, I've been working as a financial consultant XYZ also, you can understand these common sense factors, man, okay? Now, if you take employees data with which you have been working, man, in that I think we have some column called as department number column, yes or no? Now, this department number column is numerical or non-numerical column? Numerical. Now, the question arises, this column is categorical or non-categorical? This is categorical. Being numerical, it is categorical. Why? Can we keep department number column into some function? No. Can you keep the department number column into anything like average function? Meaningfully? No. You can keep this particular column into maximum, minimum, and count. Yes or no? But remember, when you are representing this column, the data in this column depicts the meaning of your particular aggregations that are happening. Average by department means definitely, don't you think it is dividing its data into 3 different categories and trying to give you? So all numerical columns are not measurable. Be careful, okay? Some numerical columns can be categorical. Is that point clear? Now, from databases as you experience, can you tell me in a simple watch, which kind of numerical columns can be suitable for categorical? The simple thumb rule I'm telling you, man, okay? The simple thumb rule I'm telling you. Keep it in your mind. All such columns that can participate in group by clause, they become categorical columns, okay? Is that clear? Any column that participates in group by clause and it can divide your data into multiple different number of categories, those columns are categorical columns in your data set. Therefore, categorical columns can be even character based also. Do you agree with me? Group by job, group by year, group by month, group by day. So understand why at least fundamental knowledge of data identification is essential for AI ML engineers. Am I clear with you? Now this categorical data is further classified into 2 types. One is called as nominal data. Nominal data means categories with no inherent order. There is no specific order that in which they should definitely get represented. They are called as nominal categorical data. Gender and country. Is there any particular rule that when you speak about the categories of gender, this is the order in which the gender should be represented, this is the order in which the country should be represented? No. There's other kind of categorical data which is called as ordinal data. Ordinal categorical data. Ordinal categorical data with a meaning is always expected to be arranged in a meaningful state. In a meaningful state. Okay? But it should be ordered in a meaningful state, but there is no rule that it should have consistent difference between the levels. The best example you can take is rankings. It is always expected that your rank is always categorized data. Yes or no? Rank 1, rank 2, rank 3. Now we expect this ranking to be in a particular order or not? But remember, there is no rule that this data should be in a particular amount of difference compulsory. Say like I'm having satisfaction levels of any particular product as one of my category I'm taking, man. Is there any rule that the satisfaction levels what we are considering should be in a particular order of 1, 2, 3, 4, 5 only? No. So they should be in a particular order, but order is not demanded. The order is not demanded to have consistent difference between the levels. Are you clear with the numerical data and categorical data? Make a habit now. Make a habit. Whenever you see any data, be very responsive to concentrate on this. Now, how to identify? How to identify categorical data? Simple. Look for columns with a limited set of unique values representing categories or labels. The best example is what I said. All columns on which you can apply group by class group. Is that point clear to you? For a database developer, a simplest thumb rule. The next thing when you're implementing decision trees or any algorithm, see what I'm giving is not specific to decision trees, man. What I started from key points to catch is in general for all algorithms. Am I clear? Wherever, whichever is specifically added as a point, there I'll be adding these key points and you should add upon them. The second thing is whenever a data set is coming to you, much of the data that comes for AI ML is purely structured or unstructured. Hello, it's unstructured. Now, when you say the data is unstructured, can we expect the data to have any metadata? No. When metadata is not available for your particular data that is existing, don't you think that it is definitely going to lack the identification of the data types? Even the size, constraints, these all things will be missing. Therefore, one of the very important ability an AI ML programmer should have is identifying data types in a data set. Don't expect the data types will come automatically in the data set. So when you're about to catch up, all the data in the data set is by default which kind of data type? Tell me. All the data is which particular data? String. It's just a string. But I think to identify numerical data, whether it is discrete or continuous, to identify categorical data, whether it is nominal or ordinal, don't you think that identification of the data type plays a very vital role? So there should be some kind of mechanism for preparing the metadata for this particular data. Am I correct? That is the only reason when Python is considered as one of the language for AI ML, because in Python it has one wonderful feature that is called as dynamic typing. Means if you supply the data to a variable, the language automatically detects the data types. Yes or no? That is the reason this language is highly accepted. Maybe many other features are also there, but this is one of the main features. Therefore, understanding of the data types is very crucial when applying machine learning models. Because don't expect machine learning models will get the input data, which is already prefixed by data types. If it is happening, it's good. But 90% of the times, it may not happen. Therefore, different type of algorithms treat numerical and categorical data in a different way. Remember that. Okay, all algorithms will never treat the numerical data and the categorical data in the same way. Therefore, recognizing your type of data and the data type is very important. Type of data and data type is different. Type of data, numerical or categorical. In numerical, discrete or continuous. In categorical, nominal or ordinal. Data type, integer, float, string. These are data types. Therefore, type of data and data type. Don't expect these two terms to be same in AI ML. Am I clear? This is very, very important construct where, see, the challenges in AML are very clear for us here now. Forget about algorithms when we'll come there, but these things are not clear. What wonders you will do? So finally, a note for any machine learning implementation, the data for analysis should be only numerical categories. Be very clear about it. Machine learning algorithms can never work on any data that is non-numerical by nature. Therefore, every AI ML expert should have the ability to give a numerical representation to the categorical data. Some categorical data is numerical. The best example is department numbers. Are they numerical or they are non-numerical? Categorically numerical. Yes or no? Department numbers are categorically numerical. See, it is a categorical data, but it is a numerical data. Am I correct? Now, job column is categorical or non-categorical? Job column is categorical or non-categorical. Now, categorical because you have different categories of jobs. But is it numerical? No. Now, if you take categorical data, which is string based, and if you want to apply machine learning algorithm, it fails. So now you should have the ability of converting categorical data into numerical data. Am I clear? If you want to take it into analytics, by implementing AI ML, this categorical data should be converted into numerical. Can you give me any fundamental feature that is available in databases where categorical data in numerical form can be converted into categorical data which is in string form can be converted into numerical form? All the students coming from database, can you give me any feature you have there? Wonderful, wonderful. You have case statements and you have decode functions. Yes or no? Are you understanding why database developers are they are ready for AI ML implementations? Because they have knowledge of data identification. The first level, I say qualification for becoming AML engineer, you're a programmer or not, those all things I'll keep it as. First, can you understand data? If you cannot understand data, you may have any technologies in your hands, but you cannot become an AML guy. That's the reason when you're attending any AML interviews or anything, they'll check in your resume. Do you have database anywhere in your resume? Do you have data warehousing as one of your additional concept in your resume? Did you work with any business intelligence reporting projects somewhere in your career? And do you have any programming languages? These all things, why they say is, these all things together can make you become an AML expert and your mindset can be changed. Am I clear? Hello. These points on this particular slide are clear to you? How we do in Python, how we do these things in our implementation, leave it on my shoulders, man. But this concept should be clear to you. Now, within the construct of the process, the concept of fitting AI and machine learning should be derived in which way? Means, whenever you're making the construct, you need to see that your idea is fitting with respect to this data identification standards, how it fundamentally fits into the criteria and composition of the AI model. So fitting refers to how well a machine learning model learns and underlying patterns in the training data. Means whatever data now you are supplying, how your AI/ML model or machine learning model will understand and it will make the constructive decisions to come in a better way. That is called as fitting. There are two kinds of fittings that can take place. When one is overfitting. See, your model is learning too much from the training data. Where imagine your data is including the noise, random fluctuations, then technically your model's decision can become too much complicated. It is as simple as sometimes we find people who sit in the interviews and we ask them too many different kinds of questions. They say like, Sir, I've learned so many number of technologies, I'm confused. Means that is overfitting intelligence. Are you getting me? Overfitting intelligence means finally his decisions are always confusing because he considers too many number of things. Is that point clear to you? You will find certain people, men, who are over-conscious before they try to do any work. And they finally don't start the work. Those people are called as overfitting people. So overfitting means your model is learning too much. And it is becoming too intelligent, where its intelligence is making you get complex decisions which cannot be really taken into consideration. Sir, why this can happen? Because you're considering every chunk of information to be handled into analysis, including noise and random fluctuations, everything you're considering. Therefore, one of the most important factor to make any data to fit properly into the AI model is what, man? Cleaning the data. Overfitting data performs well on training, but very poorly it performs on test data. Are you getting me? Training solutions will be perfect, but when you're testing, it gives you wrong result. Testing means what? When you take it into reality. Is that point clear? That's how certain times when you're working on the models, man, your model gives you 95% accuracy. Then you take it into, keep it into production, and you'll want to make it fixed with the implementation. It gives you 60%. The person gets confused. Means the real data, when it is given, you did not keep some kind of cleaning agents in your algorithm, which can remove that noise and the random fluctuations of data that is not essential. That is overfitting. Is the concept is clear? Sir, how to handle overfitting? Nothing, man. You need to remove unwanted information that is not essential for your algorithmic analysis. Therefore, every AI ML engineer should have the ability of what? Data cleaning. Is that point clear? So recognizing the data is not important. What is exact data that is essential? That is also very important. The second is called as underfitting. When the model is too simple to capture the patterns in the data, it is excluding or ignoring the data that is considered, then it is underfitting. Means information that is essential that you're not considering and you're not including, then your model underperforms. Yes or no? That is called as underfitting. Underfitting data performs poorly on both training and test also. In both the areas, it fails. In both the areas, it fails. Be very, very clear about it. So to make a model to work effectively, to give you the correct predictions, what you're expecting by greater accuracy, you should definitely see that you're balancing between overfitting and underfitting. Am I correct? It should be balanced. Sir, how much I should balance? Project to project, application to application, requirement to requirement, circumstances and situations, these things will change. We don't have any standard value for this. Okay. Certain projects, 70% accuracy is enough. For certain projects, even 50 is acceptable. For certain projects, they may demand 90. But in medical science projects, we expect that to be 100%. Space research, we expect that to be 100%. So can we just give any formula for this overfitting and underfitting directly? Definitely not. Please keep, I do not want to overload you on the process, but just to keep these things revised in your brain. I will add the concept of how to identify overfitting and how to identify underfitting in tomorrow's session. Okay? Because first these things should be running in your brain. Is that clear? If you want to revise through the video once again, man, for this session, what we recorded, you can directly go to my YouTube channel where it is available in public. Once we are into the contract, we will remove those particular videos. Till then, they will be available there. because uploading the video into your Google Drive and everything could be a construct of time for us. Therefore, I'm keeping it there. Okay. So you can directly get into my channel and you can see these videos there for your next level revision for certain demo classes that are being conducted. Okay. Tomorrow we have a session, man, because once we complete these concepts, we can go into the practical side of it very fast. Therefore, tomorrow we have a session. So let us see what's waiting for us, man. Tomorrow I'll tell you how to identify overfitting and underfitting categories. Okay. Those behavioral properties, how to catch up. Tomorrow I'll give you basic idea. Keep that spirit. Come along with the process, man. Thank you very much, gentlemen. Once again with you tomorrow. Have a nice day. Take care of yourself. Have a great day. Aditya, you need to have Python as an idea. If you're not having it, we'll give you the fundamental Python videos for self-learning and you should get ready with them. Okay.